4.2 is on standard form. Standard form we mentioned at the beginning of the notes in chapter 4. It's when you have a quadratic that's in the form ax squared plus bx plus c. And a, b, and c all have to be what kind of numbers? They have to be real numbers. Remember, it was a function, a quadratic function of the form f of x equals ax squared plus bx plus c, where a, b, and c are all elements of the real number system. So they have to be real numbers. So far, though, we've mentioned that, and then we went straight into vertex form. Vertex form is f of x equals a x minus h squared plus k. This is used more often when you're talking about transformations, moving the quadratic left, right, up, and down, stretching it. When you're talking about transforming the parent function x squared, vertex form is used the most. But standard form arises when you're solving quadratic equations. So we've got to know how to deal with that also. If you look at these two forms, what's the only thing that they have in common? Well, okay, they both have f. It just stands for y.
Amplitude and something squared.
Amplitude and something being squared. So the main thing that they have in common is whatever the amplitude in standard form is will remain the same when you have it also in vertex form. The amplitude remains the same. In our warm-up, we had this problem. Skip a line and write this down. F of x equals -3, x minus 1 squared plus 2. This is a quadratic equation. It's a quadratic because it has the square in it. Okay? It's a quadratic equation that's in vertex form. We also need to be able to write this in standard form. So the very first thing we're going to do is we're going to convert vertex to standard. If it was given to us in vertex form, could we take it from that form to standard form? Yes. Well, and someone said at the very beginning, what they both have in common, they're both f of x. And if you remember when we did linear functions, we had ax plus by equals c, that's called standard form. And we had y equals mx plus b, and that was called slope-intercept form. And you can work interchangeably between the two. You can take standard and convert it to slope-intercept form, or you can take slope-intercept form and convert it to standard. We got to be able to do the same thing with quadratics. Okay? They're both f of x equals, so that's not going to change. So basically what that means is we just need to expand this out. Well, to expand it out, we're going to use the order of operations. Order of operations says first thing you do when you're expanding something out is you take care of the what? Parentheses. Well, x minus 1, that's in the parentheses. Can those be combined?
Yeah.
Can x and minus 1 be combined? No. So there's nothing that can be done inside the parentheses. So the second thing we got to take care of is what? Exponents. Exponents in this case is squared. So the question would arise, well, how do you take care of a square?
X squared.
Not quite. What's 4 squared? 16. How can I write it in expanded form? 4 times 4. Okay, which then tells us it's 16. In order to expand this, we have to write x minus 1 squared in expanded form. So we're going to write x minus 1 squared as x minus 1 times x minus 1. The reason we do that is x minus 1 squared is not just x squared and negative 1 squared. You have to use a concept that's taught in Algebra 1. If you have two binomials being multiplied, you have to first, outer, inner, last. You have to FOIL. Does the negative 3 change, get brought along, go away? What do we do with it? It gets brought along. X minus 1 times x minus 1. We use FOIL. First, outer, inner, last. First, x times x. X squared. Outer, x times negative 1. Negative 1x, or just negative x. Inner, negative 1 times x. Negative 1x, and last, negative 1 times negative 1. is a positive 1. That's what that FOIL is out to. I'm going to go ahead and, when you FOIL, you always simplify. So I'm going to go ahead and combine like terms. X squared doesn't have anything, but negative 1x and negative 1x makes negative 2x. So we've taken care of parentheses because nothing could be combined. We took care of exponents by just FOILing out that binomial. Now we need to take care of, is there any multiplication or division? Yes, this negative 3 is being multiplied. How do we multiply the negative 3 by all of this? Distributive property. Negative 3x squared, positive 6x, negative 3. Do we distribute it to the 2? No. You only distribute it to what's in the parentheses. And what's in the parentheses is the product of multiplying x minus 1 by itself. And then the last step in order of operations is you take care of any addition and subtraction. So we combine like terms. We get negative 3x squared plus 6x minus 1. Negative 3 and 2 make negative 1. These two are the exact same equation. They're the exact same equation. They're equivalent. This is in vertex. This is in standard. This is in vertex. The first one is in vertex. The second one is in standard. Now, if we were to type both of these into a graphing calculator, it was negative 3 parentheses x minus 1 to b squared plus 2, or negative 3x squared plus 6x, right? Was it plus 6x? Minus 1?
Yep.
All right. And we get that these two are the exact same graph. All right. Which they should be because they are just the same exact equation that's just been manipulated from one form to another. Now, once again, what that brings to issue is well, if we understand vertex form, what's the point of standard form? Well, slope-intercept form works in terms of linear equations, but when we were doing word problems, what typically happened when we did a word problem? Standard form. It was always 2x plus 3y is less than or equal to 1,000 or whatever it may be. Okay, standard form occurs naturally more often, so we need to be able to work with both of them. So the dilemma is that we look at these two, the amplitude does not change. But if it's in vertex form, it tells us, hey, here's the vertex. So if you want to graph this, here's where h is, here's where k is. Standard form does not as easily tell us that. Okay, but there's a formula that allows us to figure that out anyways. Okay, so given f of x equals ax squared plus bx plus c, the vertex, and what letters represent the vertex? H and K. The vertex H comma K is at the ordered pair negative b over 2a negative b over 2a is what represents h. H is an x value. If I told you, hey, x is 2, what's the y value? There's an easy way to do it. You just take x equals 2 and do what? Plug it into the function. So if we know where h is, to find k, we just plug it into the function. And the way we write that is f of negative b over 2a. F of negative b over 2a is the function notation that just says plug negative b over 2a into the function. Okay? Thus, h equals negative b over 2a. H is just equal to negative b over 2a. And k is equal to f of, and in this case, negative b over 2a is h, so f of h. So to find k, you just plug h in.
Wow. Yeah, it seemed really confusing.
All it is a formula. If it's not in vertex form, here's the formula you use to find vertex. Alright, all this is just saying, and maybe if you want to title this, it's the formula for vertex when in standard form. When it's in standard form, this is a formula that tells you where the vertex is. Here's an example. Find the vertex of f of x equals negative 3x squared plus 6x minus 1. Find the vertex of f of x equals negative 3x squared plus 6x minus 1. When you first read that problem, first thing that should come to mind, just like it was with linear functions, the first thing that come to mind was, what form is it in? Standard or slope-intercept? So in this case, when you read this, you say, what form is it in? Standard or vertex form? This is in standard form. So that, identifying what form it is in tells you what formulas to use. Well, to find the vertex is hk. We know what the formula for h is. We've written it above. Negative b over 2a. H is equal to negative b over 2a. Well, if we look at this problem, we have a quadratic that's in standard form, so we should know what b is. B is 6 over 2 times a. What's a? Negative 3. If it's in standard form, the number that lies in front of x squared is called a. The number that lies in front of x, the coefficient of x, is called b. And the number that's by itself, which is called a, if it's a number that's by itself, there's no variable attached to it. What's that called? What is it? Not coefficient. Coefficient's if it's attached to a variable. If it's not attached to a variable, it's called a, starts with a C. Non-coefficient. It's called a constant. Okay? So A is the coefficient attached to x squared, B is the coefficient attached to x, C is the constant. So C is negative 1. But in either case, we have negative 6 over 2 times negative 3. So H is 1. Now, that's an x value. If at any point in time you want to know, here's the x value, what's the y value of the vertex, you just take the x value and you just plug it in. So the formula for k is just f of h, f of 1. So you just go to the function and you plug 1 into it. F of 1, function notation. You just go to the function, plug 1 in. So we just plug 1 into the function. K is a y value. If I said x, when x is 2, what is y? The response is you just plug it in. So if you know what h is, and you don't know what k is, you just plug it into the function. If you have a calculator, you can type it in all at once. If you don't have a calculator, you do it manually. Negative 3, 1 squared is 1. Negative 3 times 1 is negative 3. 6 times 1 is 6. Negative 3 plus 6 is 3. 3 minus 1 is 2. So we found the vertex. The vertex is H is 1, K is 2. The original problem is in standard form. We just found the vertex to be 1, 2. If we look up here, guys, the original problem is just this function here. That function is the same as this function in vertex form. What was the vertex of this? 1, 2. Okay? So we're getting the same answer. We're just applying a formula because it's not in the form that's as easy as being in vertex form. But however, we still need to know how to work with it because standard form occurs more often. Alright, so we've done problems like this on Thursday and Friday without graphing. Identify the vertex. The axis of symmetry. The min or max. And the domain and range. We did these problems on Thursday and Friday. These are very easy problems because if it was in standard form, all this information can be known if A, you know where the vertex is, and B, you know whether it opens up or down. If you know the vertex and you know whether it opens up or down, you can identify all this information. So let's say we have x squared plus 6x plus 8. So, if we're to do this without graphing, first thing is we need to identify the vertex. Well, this is in what form? Standard form. So to find the vertex, h comma k, we've got to use the formula for h, which is negative b over 2a. What is b in this problem? Negative 6, or b is 6, right? Over 2 times a. What's a? 1. If there's not a coefficient, we can replace it. We can put a 1 there. This is negative 6 over 2. So h is at negative 3. If you want to know what k is you take negative 3 and you plug it into the function. So it's f of negative 3. Negative 3 squared plus 6 times negative 3 plus 8. If you have a calculator, you can type all this in at once. If you don't have a calculator, you work it out one thing at a time. What's negative 3 squared? 9. What's 6 times negative 3? Negative 18. 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. So we know where the vertex is. Negative 3 comma negative 1. We've identified the vertex. In order to know if it's a, well, then that allows us to, well, without doing any other work, we know the axis of symmetry. Axis of symmetry is that line that runs right in the middle of the parabola. X equals negative 3. Now, to know if it's a minimum or a maximum, we have to know the amplitude. What does A equal? 1. That means it opens up. Vertex form, standard form, amplitude doesn't change. The concept of amplitude is the same no matter what form it's in. So the amplitude being 1 tells you it opens up. Opening up tells you that the vertex is a what? Minimum or maximum? So we have a minimum of y equals almost -1. The minimum y value is -1. Domain is -infinity to infinity. And the range, -1 to infinity. Good. So the smallest y value, comma, largest y value. We know the smallest y value is -1. So we've done this without graphing. Okay, now guys, part of the assignment for tonight is going to be to draw a graph. Okay, to draw a graph, all you need is the vertex and the amplitude. So if this asks you to sketch the graph, you would just do this. The vertex is where? -3, -1. If it asks you to sketch a graph, the vertex is at -3, -1. The amplitude's 1. So from that point we go up 1 over 1 in both directions. Okay, so if it asks you to sketch the picture, you just need to know the vertex amplitude. We have that. The amplitude's given to us. The vertex we found. It becomes real easy to sketch the picture. All right, and then the last part of the notes. Converting standard to vertex. Okay. Very beginning part of the notes, we took a problem that was done in our warm-up that was in vertex form, and we said, well, let's expand this out and combine like terms, and if we do that, that puts it in standard, what's called standard form. So if a problem is given to you in standard form, that means that we should be able to also work it backward and convert it to vertex form. So, inevitably, we're taking f of x equals ax squared plus bx plus c. That's standard form. And we're converting it to f of x equals ax minus h squared plus k. And at the very beginning of the notes, I start off with saying, well, here's two different forms. What do they have in common? Andrew? Answer. What do they both have in common? We answered at the beginning of the notes. These two forms. What's the only thing that they have in common? They both have an amplitude of A. Okay? H and K in vertex form, when you pull it out, tells you what B and C is. Okay? So when we look at standard form, we automatically know the amplitude. In order to write it in vertex form, we also got to know H and K. We have formulas for H and K. Okay, H is negative B over 2A, and K is f of H. So here's an example. Let's say we have f of x equals 2x squared minus 8x. Step one is we look at that and we say, is it in standard or vertex form? Okay, and why do we know it's in standard form? Because there's an x squared and a x. If it's in vertex form, it just has a x, and then it's in parentheses to b squared. Okay. So what if this would have said 2x squared minus 8? Would it then be in standard or vertex? It would be in both, actually. If it was 2x squared minus 8, it would be in both. Because look, it would have a is 2. If there is no x, then what's b equal? 0. And c would be negative 8. And then if it was, then that can also be thought of as being in vertex form, because if it's 2x squared minus 8, a is 2, k is negative 8, h would be what? If there's nothing inside the parentheses here, what's h? 0. Okay? So if that wasn't an 8x and it was just a minus 8, it would actually be in both forms. But anyways, 2x squared minus 8x is in standard form. We know a. A is 2. So when we're trying to convert it to vertex form, we know what A is. That's given to us. And we need to be able to find H. We have a formula for H. H is negative B over 2A. So it'd be negative, what's B?
Positive 8.
Negative 8.
Oh, what's already negative?
Well, so then when we plug it in, yeah, negative is going to turn into a positive. But B in this case is negative 8. Over 2 times A, which is 2. So yeah, it becomes 8 over 4. Because the formula is negative of B. And B happens to also be a negative. So it's negative of negative 8. So H is 2. And then to find K, K is we just go to the function and we plug 2 in. If you don't have a calculator manually, 2 squared is 4. 2 times 4 is 8. 8 times 2 is 16. So you get K is negative 8. So A was given to us. We just used the formulas to find H and K. We have our information that we need. So we can say f of x equals 2x squared minus 8, which is in standard form, is converted to f of x equals, what's A? 2. What's K, or H? It's H is 2, so minus 2 squared. And then it'd be plus a negative 8. So we can just put minus 8. Now, if you wanted to check your work, there's 2 ways to check your work. Algebraically to check your work. You'd have to FOIL this out. You'd have to FOIL x minus 2 times x minus 2 out, distribute the 2 in, and combine like terms. If you've done the problem correctly, you'll get this, which you will. Okay? Now, that takes a while, but it does give you a way to check your work. Another way to check your work is to, if you're going to, we got 2x squared minus 8x compared to 2x minus 2 to b squared minus 8. These two are the exact same graph. Since they're the exact same graph, that means that they represent the exact same function. Therefore, we did our algebra correctly. Is there any questions on that?